Good afternoon and welcome everyone to High Tea 2022. I am Sheila Rosenthal, Manager of Research Services at the Software Engineering Institute, SEI. For more than 30 years, the SEI Library, now known as Research Services, has hosted speakers on the intersection of library science and technology, followed by a reception. This year's High Tea will focus on an ongoing effort across the SEI in conjunction with Carnegie Mellon University to impact the future of artificial intelligence engineering. Now, please join me in welcoming our Master of Ceremonies and host for this event, Alex Van Dusen, member of the SEI technical staff and assistant design researcher in the AI division. Alex, take it away.
Hi, thanks for that introduction, Sheila. I'm so excited to be here today to welcome everyone to High Tea 2022. Just so you know, this meeting is being recorded and the recording will be available after today's event on the SEI's website in the digital library. There is time set aside for questions at the end, so please, throughout today's event, use the Q&A feature to submit your questions, and we'll be keeping an eye on those. If you wish to be unmuted to ask a question live, just raise your hand and our IT host will give you the ability to unmute your mic. So without further ado, I hope you all have a cup of tea in hand as we get started. Our program today consists of 3 presentations. The first one is a panel discussion moderated by Tom Longstaff, SEI CTO, and focusing on the future of artificial intelligence engineering. Panel members include Matt Gaston, Director of the SEI AI Division, William H. Sanders, Dean of CMU's College of Engineering and Professor of Electrical and Computer Engineering, and Rachel Dzombak, Technical Director and Head of Digital Transformation in the SEI AI Division. This panel will discuss the partnership in AI between the SEI and engineering with a focus on AI engineering and AI fusion. The panel will emphasize partnership and collaboration across CMU and highlight student and faculty involvement around AI. Now, please welcome the moderator of our panel, SEI CTO Tom Longstaff, along with our panelists, Matt Gaston, William H. Sanders, and Rachel Dzombak.
Well, thank you so much, Alex. Greatly appreciated, and welcome everybody to the 2022 Virtual High Tea. I hope everybody has tea in hand and sort of everything sort of ready to go. I'm actually really excited to sort of kick off this panel today. Historically, of course, there's been a lot of AI across CMU, and I think a lot of people sort of have an innate view of what artificial intelligence is, maybe even a little bit history of where it came from and some of the areas. Folks with enough gray in their hair like I have can sort of even remember the first wave of AI. Yes, Bill, I see that as well. And can sort of remember all the excitement around the first wave and then sort of the AI winter as we went into that. Now we've come into a new renaissance of AI. But part of what we've been thinking a lot about across the university, and especially within CIT and the SEI, has been the whole nature of how do you engineer AI systems, AI engineering. So I'm really excited that I've got like the people at Carnegie Mellon to come and talk about what is it that we actually mean by AI engineering, what is it that we can say about it today, and what are the opportunities for all of you in AI engineering that you might go to work to in the future. So what I'm going to do is I'm going to allow each of the panelists to introduce themselves a little bit, and I'm going to start with the first question. So please introduce yourself and you come up with a little bit of a discussion on the very first question that I'm going to ask. So Bill, I'm going to start with you, sort of in there. So if you could introduce yourself, and could you help distinguish between software engineering and AI engineering? How are they alike and dissimilar?
Well, thank you very much, Tom. And I should say thank you to you and the other organizers for inviting me to represent the College of Engineering here. As you said, I'm the Dean of the College of Engineering. I'm a faculty member in electrical and computer engineering, in computer science, and then also in the Heinz School of Policy. Like many of us here, I'm very interdisciplinary in the way I approach problems. To get to your question, though, which, and I don't know if I'll answer it exactly, but AI engineering, I should say, is a cornerstone of what we're doing within the College of Engineering. And to distinguish it both from software engineering, as you asked, and from AI as a general field, I think we take engineering in the name for what it really is, not a college, but a verb, right? The action of building a system, an engineered system, we sometimes say, and then in NSF, but the process of and the artifact that's created that is that system that has better functionality because it has AI orchestrated into it. And so when you think about AI engineering, there are really two components. One is how can AI transform the process and discipline of engineering itself, how we do our job as engineers. And engineers dream about things that make the world better, then they invent and they design and they build those things. And secondly, how can we orchestrate or embed or infuse AI technologies into the systems, the products that we build themselves in order to make them function better. And so these two things is what we think about in AI engineering. And in the College of Engineering, we're doing research that's advancing both of those. We're also doing education. I will say that this last fall, the fall of 2021, we introduced a new master's program in AI engineering in our campus in Kigali, Rwanda. And it's a program that starts from the system point of view. It teaches the students how to do the discipline of AI engineering. And the systems that it focuses on are systems that are uniquely tuned to solve problems that are local to the African context. And so you see courses and, of course, machine learning and deep learning for engineers, but you also see courses in the tools of AI engineering, the software tools that you enable to do it, and in the issue of the trustworthiness and the ethics associated with the use of AI, right? As engineers, we have to make sure the things actually do what they're intended to do. That's the trustworthiness aspect. And secondly, they need to act in ethical and responsible ways. I'll just finish by saying I'm sure there'll be more that program has been very successful in Africa. And this coming fall, we are introducing 7 new master's degree programs in AI engineering in Pittsburgh. And essentially, those 7 programs will all share a common core, about 42 units in which they'll teach the discipline of AI engineering. But then the remainder, the other 60% or so of the degree, will be a particular kind of AI engineering in autonomy, AI engineering in civil infrastructures, AI engineering in electrical engineering, chip design, and so forth. And in all of those cases, we want to, if you will, create engineers that are engineers first, but are a new breed of engineer, these so-called AI engineers that Tom was asking about. So I'll end there. I'm a professor. I can go on forever, but I think others should have a chance.
Well, thank you, Bill. That really, I think, sets a great sort of overview and a framework for this whole idea of AI engineering. Rachel, I'm going to turn to you next. If you could sort of introduce yourself and give us your take on sort of the distinction between software engineering and AI engineering from your point of view.
Sure, Tom. And thanks so much for having me today. My name is Rachel Dzombak, and I am head of digital transformation, a technical director within the AI division here at the SEI. And over the past year, I've been working with our team alongside with our collaborators on campus to answer this overarching question. What is this field of AI engineering? I think it's a great provocation that not everybody wants to do, to invent a new discipline. I feel really lucky to be engaged in this challenge because it's a big opportunity space that we have here. Just like Bill, I have a really multidisciplinary background and take a super multidisciplinary approach. I'm a civil engineer by training who's now working in AI systems, AI science. And so trying to bring these fields together and also say, what can we learn across these different disciplines is critical, I think, to advancing the field of AI engineering as well. And, when we're talking about AI engineering, at the core, I think what we're talking about is being able to, AI engineers work to develop tools, systems, and processes to enable the application of AI in real world contexts. And that's really what engineering is all about. It's not about pushing forward the theory. Of course, we have people who do parts of that, but when I think of engineering, it's really about solving problems that matter, thinking about how do we leverage technology to push forward and address problems that affect people, that affect systems, that affect how we all live and work every single day. And as we're distinguishing from software engineering, I think the big pieces to remember is that there's a lot of concerns in traditional software engineering that are exaggerated or amplified when talking about AI systems, particularly when dealing with AI systems that include machine learning components. There's, of course, an inherent uncertainty, and this is the place where I think bringing together these fields of traditional, if you can call it traditional engineering skill sets, mindsets, practices with looking at artificial intelligence and its application is strong, because that's dealing with uncertainty, dealing with assumptions is the bread and butter of engineering as far as I see it. You have to figure out what are the steps forward I can take and really empower people to have agency amidst high degrees of uncertainty. When dealing with AI systems also, you need really diverse teams that include software engineers, but also include data architects, that include folks who have an emphasis on the hardware, software, and the ways that they interchange. As Bill mentioned, you need people who think about AI assurance, who's understanding the ethical side, who's understanding how people are actually leveraging these tools to make decisions. And while, of course, it's a focus in traditional software engineering, when we're dealing with AI systems, you also have to have a keen focus on managing data and also recognizing that data can change at a very different rhythm than other parts of the system. And it can lead to emergence, these emergent effects that might come forward. And so I think at the end of the day, I don't know if it's a core difference. I think software engineers intersect with it also. But as we're moving towards defining this field of AI engineering, we have to be particularly focused on, we cannot control every single outcome. That's not an option. And it's about understanding how we deal with these emergent consequences, how we deal with these emergent effects of systems, and seeing both the opportunistic side of that. It can enable engineers to solve problems in incredibly new ways based on being exposed to a set of options they might not have previously thought of. It can spark creativity in that way. And it can also lead to consequential failure, which, if it's in the context of, I always say, if Spotify recommends you the wrong song, you might be temporarily upset, but you're going to recover from that, I'm sure of it. But when dealing with the problem spaces that we work in national security, the problems that we're engaged with at our campus in Kigali, dealing with food insecurity and water resource management, the stakes are high. And so we have to be thinking about, what does uncertainty look like in those contexts, both from a technology side and a problem side, and the way that those come together. I guess I also can talk a lot, so I will pass it over to Matt.
Yeah, that's fantastic, Rachel. So Matt, I'm going to bring you in, but I'm going to throw you a curveball, because I'm not going to ask you the same question, because I know you're all prepared to answer that. But you've got a long, deep history in AI, coming into this. And I guess what I'd really like to hear from you in terms of the cross-disciplinary side, when you really think about AI engineering as a cross-disciplinary research topic, how do you view that across the entire university, and what sort of other areas of expertise do you think need to be pulled in to the whole world of AI engineering to make it successful? And of course, introduce yourself, please.
Well, thanks, Tom. So I'm Matt Gaston. I'm the director of a new division at the Software Engineering Institute called the AI Division. We focus on AI and AI engineering, obviously. It's a great honor to lead that new division and be a part of it. It's also a great honor to be here today with Dean Sanders and Rachel. And thanks to Sheila and the SEI's Library Services team for putting on the overall event. So to your question, Tom, which is really about the interdisciplinary nature, I would say required to do AI as well as AI can be done, or to do AI engineering. It's critically important. And I'll say, your original question to Bill and Rachel was, how is this different than software engineering? Well, I think I can use that question to answer the question you posed to me. AI engineering is obviously built on the foundations of software engineering, right? We've had software engineering as a discipline for, I would estimate, nearly 40 years or more. There's a lot of lessons learned from disciplines like software engineering, but AI engineering introduces new and different both opportunities and challenges. To get really interdisciplinary, there are serious design considerations when thinking about how to construct an AI system for a particular problem. And design thinking is not necessarily part of a traditional computer science or AI curriculum. We're also finding that AI and the use of AI capabilities has significant policy implications. Here at CMU in Bill's college, we have a great department on engineering and public policy. And that type of thinking is certainly necessary to understand where are the right uses for AI, how can AI be used to solve certain problems, and what are the implications beyond just the technology capability that these tools might provide. And sort of extending even further, I think a business perspective, which at CMU we have world-class schools of business. The Heinz College, as well as Tepper School of Business itself. I think business thinking around AI and where are smart places to apply it. How can it be used as a tool for growth, as a tool for job creation, those sorts of things. So just a few examples that get at building on the foundations of many different disciplines, extending them, and my hope at least is enhancing them as areas of study, and maybe more importantly from an engineering perspective, areas of application to solving real world problems, as Rachel said.
Yes, and I'm on mute. So actually, thanks. Excellent, Matt. Bill, I'm going to actually have you respond to that a little bit. From your point of view, especially as the dean over there in engineering, it's pretty obvious that you're going to bring in people from computer science and you're going to work with computer science. It's pretty obvious that you're going to work across the engineering schools, especially with the new programs that you have there. But where do you go outside of the traditional, programs of computer science and engineering? Where else across CMU do you want to sort of bring in partnerships as you think about AI engineering, and especially maybe research and future centers and really other areas of leadership in AI engineering that we'll have not only at CMU, but across the world? What do you think?
Oh, thank you, Tom. And you named a lot of the places. I think to say it, we all said a lot of words about what AI engineering is, but simply said, it's using this technology of artificial intelligence to do engineering as a verb, and really having an engineering mindset when you think about things. So you're exactly right. We need the experts that are developing the algorithms of AI, right? And those reside we're one of the very unique schools that has a department of machine learning. So that's a fantastic place for us to collaborate with. We have a fantastic statistics department that's working in AI in our Dietrich School, right? And so that's another place that we find collaborators. But you're right, it goes well beyond that. Policy issues are very important. And as you said, we have our engineering and public policy department. The motto of that now over 50-year-old department is the research they do is in policy where technology really matters. So these are people who can understand the technology deeply. They often are engineers or computer scientists by training, but they but they really work on policy issues. Of course, the Hines School, the public scholarly school, business issues in our Tepper School. And let me end by one that's really one of the most important. And we are using this now in some of the large center proposal we're writing. It's very key that we have psychologists. It's very key that we have ethicists and philosophers that think about the societal impact of what we do. And so we are working together with people from those departments in our Dietrich School. And I would say we haven't much yet, but I think it's very important to work together with political scientists. And at CMU, that means our IPS department that really looks at how international politics can affect many things, including technology. So it's everywhere. It's everywhere. You know, there's even design thinking in our fine arts school that's very important. So it's absolutely everywhere.
I'm actually really glad you mentioned fine arts as well, because, you know, there's a whole lot of what's going on around AI engineering that is all about sort of the human experience, right? And sort of what's happening with the human experience. Rachel, I'd like to ask if you could pick up on a thread, especially not only with the human experience and things there, but the ethical use of AI and sort of the idea that as we as people begin to interact with AI, what about AI engineering is going to help keep it on the ethical side and sort of on the, the human side?
Yeah, well, I think that's possibly even reframing your question to understand how can we as humans place bounds on where and how AI intersects with us. And this is not a new challenge. You know, I think 10 years ago, of course, coming out of Silicon Valley was the move fast and break things mentality, and just saying let's grab new technology, see what's possible, and not worry about the consequences. And honestly, if you go back in the history of engineering, there's a long track record of that mentality. I think, again, because of how AI systems are being used, because of the data that they draw on, again, it's really amplifying concerns that were pre-existing in many ways. So I think it invites this much broader conversation about both who's involved and what does it mean to be an AI engineer, which is super exciting because it also serves a role of diversifying who counts as an AI engineer. We've traditionally been very technically focused of the person who's developing the algorithm. But of course, to make these systems successful, we have to include way more than that. And so I think the big piece of it is trying to figure out this very open question of what does it mean to be proactive about AI ethics versus reactive? And then if you figure out what it means to be proactive, how does that translate into each of the individual components that comprise an AI system? And that's a lot of systems thinking that's necessary, a lot of moving pieces, and a lot of critical thinking to say, you know, what are we trying to do? Who are we trying to do it for? Who could be at risk? But with the data sets that we're using, with any of these component parts, about the decisions that are made, what are the contexts in which we are implementing these systems? What context are we not implementing systems in? And what I think is the biggest piece of it right now is it is too big of a problem to be solved by any one discipline. You know, it always, when people say this is the place to answer this hard question, that those words always scare me a little bit, because what we need to be drawing on everyone's different perspectives and get different ways of solving the problems, different way of seeing the problems, to get to a place where we're actually triangulating around and being able to give some guidance on what does it mean to do ethical AI? What does it mean to do responsible AI? And I'd say, I know in our work, we're prototyping a lot of that right now. We would never claim to have all of the answers, but we're trying to figure out, how do we take the many frameworks that have been developed? It seems like every company, every government organization has their own set of ethical principles or AI ethics frameworks. And then that translation step, as Bill said, getting away from the words and getting into the state of practice, it's really hard. And I think the piece that we're looking at is, what does that practical implementation look like? And then how does it drive new challenges? Because I know we're already seeing that as we try to work with software teams to implement our work on responsible AI, the pushback is coming up, oh man, this takes a lot of time and you're slowing down our development process. And so I think it's just a negotiation and a continual improvement process that's needed to think about how we're answering some of these really hard questions about what it means to do ethical AI well.
Alex, I think there was a question from our audience out there that's related to this. Can you go ahead and pull that in?
Absolutely. So we have a question from Caroline Coward from NASA. They ask, what is SEI's activity around ethical AI? Specifically, how are SEI and CMU addressing hidden biases in algorithm development and other challenges in this area?
It's a really important question. I'll let any of the panelists who want to jump in.
I'm happy to start, and then Matt and Bill can add on.
Please.
But I'll say that I think we're in the stage of figure, kind of what I said in my last answer, we're at the stage of figuring out what does it mean to do ethical AI. So we have a portfolio of research that's unpacking what are tools that people can use, who needs to be in the room, who's responsible on teams to do ethical AI, how does it translate into these individual component parts. We're also thinking about what does it mean to work with our government customers to get them on board with these principles as well. Of course, the DoD in our work has a strong set of ethical AI principles, and it's an open question still amongst all of the services, all of the agencies about that translation piece of what does it mean to put them in practice. We were part of the Defense Innovation Unit's drafting of responsible AI guidelines. And we're currently doing a lot of work with them to say, how do we start to use the tools that are associated with those guidelines, which is a set of worksheets, to actually go about implementing these practices as they're bringing new vendors into the DoD space. So lots of practice work. And then I'll also say we're collaborating with the College of Engineering through Bill and through the other faculty to think about what needs to be embedded in curriculum. Because traditionally, the critique of engineering curriculum has been that you go through your years of engineering school, and then you sprinkle a little bit of ethics on top and you say, okay, you're good to go. And I think that CMU is such a leader in challenging that notion and thinking about how do we do this integrated education from the start? How do we think about the ethical concerns that are needed and bring that into students' vernacular, even when it's not as exciting to them at first as what's the latest and greatest in technology.
Yeah, Bill, I see you're off mute.
Well, I've been off mute all the while, but I'm happy to say something quick. And I know we've got a lot to cover, so I'll just be quick. But I think Rachel said it very well. You know, we start from principles. We know as engineers, and ethics has been an important part of our curriculum. My gosh, 40 years or more since I was an engineering student. But what we really need to do is, because this is a new and emergent field, is to define what those principles are, and then through specific investigations, understand how to, in a very, I'd say, practical way, quantify when AI is behaving in an ethical or non-ethical way. And how do we do that? My father always taught me that if you can't solve a problem in the general, solve it in the specific. And so we have specific faculty, both in School of Computer Science and in engineering, actually, and in our Heinz School of Public Policy, that are looking at very specific instances of the use of AI and trying to quantify the notion of ethics in those systems. So those could be vision systems, they could be traffic systems, they could be systems that are used in the police force. All of these things are specific examples that are being worked on by faculty in some college at CMU. So.
Yeah, and I think the whole, the sort of context of the question about how do we actually look at inherent bias within AI systems, these are non-trivial. They're non-trivial outside of AI systems, so they're completely non-trivial inside as well. Alex, I know there's another Q&A question I think that builds on this as well, and I want to throw that one to Matt if I could. But Alex, do you want to come off and do that one?
Absolutely. James T. Wessel asks, the IEEE has published a compendium of software ethics. Do you see a similar artifact in AI?
So I think the easiest answer is yes, of course. As I said in the introduction, AI engineering as a discipline must and will build upon existing disciplines like software engineering, like what IEEE has published on software ethics. I do know that IEEE right now is also pulling together various groups to look at standards for AI, specifically in the trustworthy and responsible AI space. And if you know IEEE, they do great work, of course, but these standards bodies, they take their time and they deliberate, and they think carefully about these problems. And so I do expect over the coming years, we will see similar standards to what IEEE has done in software ethics. Tom, if I could add one other point to the conversation around ethics and responsible AI, and coming down a level in detail, our approach at the Software Engineering Institute has really been focused on what we call beyond accuracy. And I want to give credit to another dean from Carnegie Mellon University, Dean Marshall Hebert from the School of Computer Science. He shared that term with us. And we think this is a really important and nice way to summarize how to think about building AI components, really specifically machine learning components in these systems. So one additional thought on beyond accuracy. When we think about modern machine learning specifically, and if you're a machine learning engineer trying to build a specific capability, the typical focus is accuracy. How well can I perform on a specific task, be it facial recognition or object detection or object classification, or more complicated things, and how well, what percent accuracy can I get on that task? We are very interested in, and only in the early days of exploring these ideas, how do we build additional criteria into the types of optimization functions that can account for ethics, fairness, interpretability, uncertainty quantification, all of these things. And so how do we go from a sort of singularly focused optimization function to a multi-criteria optimization function with a lot of thought that would go into how do you design that metric and that you're measuring across these different considerations, specifically including ethics.
That's really fantastic, Matt. Thank you so much for getting down in there, because that's a lot of the places that both we are internally investing within the SEI and putting sort of funds into that. And Bill, I know that's a key, and a number of faculty members across CIT as well, sort of coming into it that way. But I know there's a lot of students on the in the audience here, both graduate and undergraduate. What I'd really like to do is turn to their point of view and talk a little bit about what opportunities might exist both today and in the near future for students that are already at Carnegie Mellon to get involved in this, to get involved in AI engineering, to get involved in the ethical research or some of the other areas that we have. Rachel, I know we do a lot with sort of interns and things that way. Can you talk a little bit about the opportunities there first, and then I want to give Bill and Matt the opportunity there as well.
Sure. We, as you said, we certainly have interns who work with us, both undergrad and graduate. We had an undergraduate intern from the College of Engineering working on our beyond accuracy research over the past, up until the summer started. And so that was fantastic because I think the thing is all of these questions are so big and no one knows the answer to them that it's very exciting for anybody to engage in them. And I think it's very, especially for undergrads and grad students, to jump in and just put point of view out there, to try things out, to experiment a bit, to try to engage in these answers. The other thing that we're doing in our work in AI engineering is we are trying to grow a collaborative ecosystem to define what this field means, to define a body of knowledge. And so as part of that, we hosted in March a symposium through AAAI about what it is to do AI engineering. And so we had 3 tracks on human-centered AI, robust and secure AI, and scalable AI. And that was a great place. We made it really interactive, much like this panel. And so we had students from CMU, but also from Clemson, from Oxford, from other places, as well as faculty, as well as folks from FFRDC and industry, to come together. We had about 35 folks just to try to get agreement on some shared language, to have debates about where people see things differently. And I think that was a great opportunity also for students to engage, because it allowed them to see, hey, I'm sitting with all these experts, and there's a lot I can contribute here too, because the space is so big for people to give input into right now.
Excellent. Bill, from your standpoint, what are the opportunities for students, both sort of now and coming into the future? Where can they really get involved, and how do they do it? How do they get there?
Okay, that's a great question, and I can only scratch the surface. I know in the amount of time you want me to answer in. But let me start by saying AI research. I'll talk both about research and education very briefly. Mm-hmm. AI research is pervasive throughout the college. In an in-depth research visioning activity that went on in 2019, and I'm sure the number is even higher now, of our about 250 faculty in the College of Engineering, and there are many more as well in computer science and the other colleges I talked about. But within the College of Engineering, about 80% of the 250 faculty said that they used in an integral way artificial intelligence, and specifically artificial intelligence engineering, in their research. So it's, even if you only walk up randomly to a particular faculty member, she or he probably is using AI and AI engineering in their research. So you'll find it everywhere. We have been for a long, long time a very computationally based engineering college, and now I think it's quite. I don't go around saying it, but I think we are among all of the top engineering schools, the AI engineering college. So you want to get involved. There are many different ways. Some of our departments have clearinghouses, web pages where faculty register projects that they would like students to get involved with. You can talk to your instructors if you think what they're working on or what they're teaching in their classes is interesting. And more likely than not, you'll find a project that relates to AI and AI engineering. And a big fraction of our undergraduates get involved in research work when they're undergraduate. I don't really know the percent. It's hard to find out, but somewhere between 50 and 100%, or 50 and 75% of our undergraduates are working on research while they're at CMU.
Yeah.
It goes without saying that if you're a graduate student, whether you're a master's student or a PhD student, you can get exposed easily to AI and AI engineering related research as well. And then I'll just close by saying that there are some real educational opportunities, right? I already mentioned that in our Department of Machine Learning in the School of Computer Science, several years ago, we established the world's first undergraduate degree in AI. And so that's an opportunity. There's opportunities to do concentrations in AI as an undergraduate within a discipline. So that drives home more AI engineering. There's the new 7 master's degrees in AI engineering in Pittsburgh that will be kicking off this fall. And talk to the individual engineering departments if you'd like to get involved there. There's the already ongoing one in Africa. And although it hasn't been announced yet, there's a collaboration going on between the College of Engineering, the Dietrich College, and the School of Computer Science in looking into a certificate program in ethics and AI. So, it's popping up everywhere. The landscape is changing quickly. There's so many, and if none of that works, send me an email and I'll try to connect you to someone. So hope that helps.
Thank you, Bill. Matt, I'm actually going to ask you to even expand the aperture beyond that a little bit. I know we've got tons of opportunities around Carnegie Mellon. Where do you see the opportunity, sort of collaboration in AI outside of CMU and between different, both academic institutions, but the government and private sector and other places. Where do you see that collaboration moving?
Well, I think that's a huge question, and I personally liked Bill's answer of just send Bill an email. All joking aside, well, I think one important thing to mention is both local and more global. There is infrastructure, right? We have the Pittsburgh Supercomputing Center here that at CMU and in Pittsburgh. That has resources and has been growing their focus on data-centric computing, AI-centric computing. And you can apply for time on machine, you can apply for small grants. So there's some resources available at places like the Pittsburgh Supercomputing Center. And I think that goes for other opportunities, right? The students at CMU have amazing opportunities in front of them. They can go all over the world for different internships. One thing that I would like to ask is if people go off and are involved in a great AI program where they're changing the world through the application of AI, come back and share with your faculty that you work with, or call us at the SEI, send us an email maybe. Tell us about that success and how it was made to work, and the processes, practices, and tools that were used to have a large-scale AI system be successful. We're also quite interested in failure. I think something that will drive ultimately an engineering discipline is understanding the cases where the system didn't work the way we wanted it to or we expected it to, and starting to accumulate knowledge around that. There are some resources like that out in the world. There is an AI incidents database, but we may, CMU with the rich amount of activity in and around AI may be another source of that type of information. So as people go off and just experience trying to do these things, finding ways to share it with others is really key.
That's fantastic, Matt. Hey, we're almost out of time, believe it or not. This it goes quickly in terms of where we are. We've got a couple of questions left online, but what I'd like to do is I'm going to prep all of you. We're going to get to the questions online first, and then I'm going to want each of you to close with just a brief statement on what you think the future of AI engineering is. But Alex, let's go to the questions first.
Yeah. So the first question we got, I think, fits in what we were just talking about. Is it realistic to get an AI engineering job after undergrad without getting a PhD in AI?
So aside from just saying the answer is yes, anybody want to go into detail?
Yeah, I'll just say agreed, yes. I think it's the big open question right now in the national security space, the government space, and in industry is how do we meet the demand that we have for the workforce? And so certainly I think having a PhD in AI can set you apart on a trajectory, but there's many different pathways. The biggest thing I would caveat is that right now, I think we did a study of AI engineering job descriptions and job descriptions that would lend themselves towards AI engineering, but are called something totally different. That's the place where, especially, I think industry is evolving very rapidly right now, how they are terming these roles, what the qualifications are, what is the experience levels that they're looking for. I think there's a mismatch between right now how job descriptions read, and then what we're actually seeing, who gets hired, who fulfills those roles. And so I think that's definitely a big space to jump into right now. It's also a place of being willing to cross-train. I think going into a role that is something different, but saying I have this interest and I want to grow my skill set. I know we do that a lot on our team of bringing people in who have a background in data science or software engineering and thinking about how do we get them up to speed on AI and machine learning systems in order to grow their capacity over time to get on the other side to be an AI engineer. But because it's so evolving right now, it just takes time, I think, for industry to sort out what goes into a job description for a role that is changing every single day as new tooling is coming out, as well as new dimensions of what it means to be an AI engineer.
Thanks, Rachel. I think what I'm going to do is and say that's a great answer, and why don't we leave that one at that. Bob Stoddard had a question there, but it's really more of a comment. So, Alex, if we can just forward that through so everybody can sort of see the comment, I think we'll close that one out. And then what I'd like to do for just the last couple of minutes is go to each of you with sort of your view to the future to kind of close out. Matt, I'm going to start with you. What's your What's your view of AI engineering in the future?
Well, I think I'll actually expand on Rachel's answer to the last question about getting jobs without PhDs in AI. I think that is actually an indicator for the success of an engineering discipline, right? So as we grow the discipline, as the discipline is curated by the community and advances and is adopted into curriculum and other things, tools and processes and practices. We should see more people being able to come in and have a very positive effect on engineering problems that involve AI and the application of AI for engineering problems. So I think, the more people we see involved in the technology and having, a positive effect on how it is built and applied in the world to solve real problems, that is an indicator that we're maturing a discipline, that there is an adoption of that discipline, an appreciation and use of that discipline, and that it will grow and evolve with that community that's created over time. Just as a real quick note, we've done some work at the SEI where we worked with technicians that actually, in some cases, don't even have degrees, college degrees, and really worked hard to figure out ways and different methods and different human-computer interaction concepts and different understanding of data so that they could participate in the process of managing, operating, even upgrading and retraining AI systems. And so I think there is a promise in this direction. Again, as we mature in the AI engineering discipline.
That's fantastic. Thank you, Matt. Bill, what do you think? What's the future of AI engineering look like?
So just to follow on with Rachel and Matt, you absolutely don't need a PhD. In fact, you don't need a PhD as an engineer to do most things. So although I think several of us on this call have a PhD, I've said that, and now answering your question about the future of AI engineering, I think it's a young field that's still evolving. When we were thinking about how to offer an education in AI engineering within the engineering college here, there was a full spectrum. We could have created an AI engineering department, right? We thought about that. Many people asked me if I was going to create a new department. And I thought that was the wrong thing because that stovepipes AI engineering away from the engineering disciplines that it could transform. So I think the right answer is the middle ground, like we've done it. We're offering degrees in AI engineering, but not even generic degrees that are linked to the engineering disciplines that AI, through thinking about AI engineering, can transform. So, at the other end of the spectrum, you say, why do you offer a degree at all? Why don't you just offer a new civil engineering curriculum that has AI infused into it in every way? And that might work. But right now at this stage, I think we need to be deliberate enough with respect to a core that all engineers who want to practice AI need to know. But then we need to integrate that in a very holistic way with the engineering discipline itself. So the future of AI engineering is that it will be pervasive in the engineering discipline itself, and it will transform the engineering discipline. And if we are successful, maybe every engineer will be an AI engineer, rather than having to create a separate stovepipe discipline. And I think in all of that, the key distinction between, let's just say, the general field of AI and the field of AI engineer is that AI engineers will put the system first, and then they will look at how to engineer that system using AI techniques and how to orchestrate AI into the systems themselves to make those systems perform in a trustworthy and ethical way while providing greater functionality. So I think that's the future. May be that every engineer is an AI engineer.
I love that, Bill, because as you and I have talked about many times in the past, that's where we saw cybersecurity engineering going as well. Is that every engineer would have to know a little something about cybersecurity engineering, coming into it that way. Rachel, I'm going to give you the last word.
Wow.
In terms of what the future of AI engineering looks like from your standpoint.
Sure. Well, it echoes what has previously been said, so I'll keep it short. From where I stand, it's really connected to those problem domains. We have really hard problems to solve. Infectious disease, supply chain challenges, national security challenges, climate change. And at the end of the day, AI is a tool that can be engineered towards addressing any of those problem spaces. So for me, it echoes what Bill said about everyone having this as a tool in their toolkit. But it's about being able to say, how are we getting traction on these hard, wicked problems? How are we moving towards seeing outcomes that we want to see? And can we leverage these AI systems or AI components of systems to help engineers think about new creative solutions, new opportunities, new ways to address the problems that really need work today?
That's wonderfully inspiring. Thank you, Rachel. And thanks to all of my panelists. This was really a fantastic discussion. Rachel, Matt, Bill, thank you all. I will just say to everybody who's out there listening to us, if you have any follow-up questions or would like to reach out, I know personally that each one person on the panel and myself would be happy to hear from you and respond. So please do reach out if you have questions or would like to get involved. And with that, Alex, I think I'm going to turn it back over to you.
All right. Thank you so much. So thank you so much to Tom and our panelists, Matt, Rachel, and Bill, for that discussion. And thanks to our audience for your questions and your participation. We heard a lot about how CMU has significant and growing leadership in AI with partners throughout the university. AI engineering is more than software engineering. And as we move forward, we'll need to think about the way we craft the discipline of AI engineering. Keeping in mind, as Bill described, we must consider how AI will transform the process and discipline of engineering itself, as well as how we will embed AI technologies into the systems in order to make them function more effectively. There are many opportunities for current and future students to, as Rachel touched on, participate and engage in this challenge and apply these solutions in a real-world context with high degrees of uncertainty. Also discussed in depth by all of our panelists, while AI engineering is built on the foundation of software engineering, AI engineering offers new opportunities and challenges, and we can build in many directions and many areas of expertise and perspectives, from psychologists, ethicists, philosophers, designers, business leaders. AI engineering will need to involve subject matter experts in varied areas, including software engineers and beyond. And looking forward, we expect CMU to drive a new standard for AI engineers, not just at CMU and the SEI, but across the world. Again, thank you all so much for such a rich conversation. And now, next up is our second presentation, Artificial Intelligence, Impacts and Roles for Libraries. So joining us today, we have presenters Keith Webster, Helen and Henry Posner Jr., Dean of Libraries, CMU Libraries, and Hajin Wang, Liaison Librarian, Program Director for Open Science and Data Collaborations, CMU Libraries. We're running a little short on time here, so I will let them tell you about what they're going to present on. So please join me in welcoming Keith Webster and Hajin Wang.
Thank you so much, and good afternoon, everyone. It's wonderful once again to be with you for the annual SEI High Tea. It feels like just another holiday in the annual calendar, because every year we do this wonderful event. I do hope next year we'll be back enjoying the wonderful selection of snacks that Sheila and her team are able to entertain us with every year. I'm going to begin by offering a brief overview of artificial intelligence and its growth as a discipline, and also say a bit about some of the questions we are wrestling with in libraries as we understand the impact and the affordances of AI. I'll talk fairly briefly and then hand over to Hua-Jin, who is much more engaged in the ins and outs of our support for AI, particularly around data, and then we will have time for Q&A at the end. I don't have time to articulate an argument on this point in any depth, but I hope that we can agree that properly done, it is good to have a different intelligence to ours working alongside us, helping to diversify the views that come together to form insights and make decisions. In the next decade, I think we'll focus on how AI will liberate us, just as the second industrial revolution liberated us from heavy lifting, from menial mental tasks. William Ross Ashby coined the term amplifying intelligence. Sometimes we might think of that as cognitive augmentation in his introduction to cybernetics, published in 1956. In 1955, three professors at what's now known as Carnegie Mellon, Alan Newell, Herbert Simon, and Cliff Shaw, wrote the first program deliberately engineered to mimic the problem-solving skills of a human being, even before the term AI was first coined at the 1956 Dartmouth Conference. Early computer users at Carnegie Tech gravitated to questions of human and computer logic, what Herb Simon termed intelligences artificial and natural, and which he investigated through observing students and their interactions with logic puzzles. Out of this emerged the university's reputation in matters of human interaction with computer interfaces and programs, how computerized thought patterns might mimic or differ from human neurological patterns. By 1965, the computer science department had been formed. That became the College of Computer Science in 1988, and the machine learning department followed in 2002. And Bill Sanders already mentioned how fortunate we are to have that department on our campus. And today we see AI cutting across many aspects of the university. For example, a deep focus on deep learning, no pun intended. And I'll say a little bit more about AI across the university in just a moment. One of the ways that librarians like to look at the evolution of a field is through the network of publications. This is a visualization prepared by our friends at Elsevier, where they have mapped the intersection of thousands of journal articles on artificial intelligence and clustered these into a number of key themes. As we look at the growth of AI in journal literature over the last 20 years, you can see, as you would expect, a steady upward trend over time. What's particularly interesting, though, is to look at those different disciplinary clusters or subclusters and see where the real growth has been. And it's in the top three lines: machine learning, neural networks, and computer vision. And that speaks not only to the growth of the discipline writ large, but particularly some of the key foci at Carnegie Mellon. We are one of the most prolific universities in the world in producing AI research publications, far and away number one in the United States. And it's perhaps not surprising to see our interests and expertise aligning with that global shift. Bill has talked, as have our other panelists, really about AI largely as it is seen through the lens of engineering and computer science. We did touch, and I'm grateful to all of the panelists for doing so, on how we see AI represented across all of the colleges at CMU. I threw in a few slides whilst my colleagues were talking, just to illustrate this for those who may not know the CMU landscape terribly well. But just as examples, we've heard about our philosophers and their focus on AI ethics. There's a lot of work with people like Jay Aronson in the Department of History on artificial intelligence and human rights. Our colleagues in the Block Center looking at artificial intelligence and analytics and how those can be used for positive and good outcomes. The Tepper School does a lot of work in areas like healthcare and machine learning, engaging with business leaders to ensure that they are making ethical and sound decisions as they deploy machine learning. And we've heard also about the importance of our College of Fine Arts and the creative activities that they are promoting. So just some examples of how AI is being used in design. There's a fascinating course in the art school on creative artificial intelligence. And all of this speaks really to Carnegie Mellon as a university where AI touches every aspect of the university. And just as we see it touch all departments and schools, so we recognize that it will affect how research libraries perform and carry out their services, and how the various kinds of data that we hold in our repositories will be used in the future. For the moment, the landscape in libraries is both complex and unclear. I've spoken at previous high teas about open science and how it is shaping the evolution of our libraries. I'll say a few words about the landscape of science and how open science touches on that, but I know that Huajin will say much more about this in just a moment. Accelerating scientific advances is an important grand challenge of our time, and AI has become an imperative for science. It's important to recognize, though, that human limitations will curb scientific progress. When scientists write papers, when they look at the world, sometimes there are errors and biases. There is poor reporting in papers. Sometimes the work is not systematic or complete. There are many cases of errors simply because scientists are human and make mistakes. And often we read about published papers being retracted after some scrutiny about the results. There was an element of that in the early days of the pandemic, for sure, as humans expedited science reporting in a quest for treatments and vaccines. There are plenty of other examples. One that I've used in talking about software curation is the experience of a graduate student who was trying to reproduce research in the early days of the financial crisis more than a decade ago, looking at a paper by two influential economists, which had influenced many government and central bank policies. And the student found out that there had been an error in the Excel table that had been used for the research. Another important problem is that reproducing the results of a published paper is often challenging because authors don't include enough information that really is crucial to understanding how their methods actually work. Work is being conducted in a number of fields to leverage the semantic web to develop and extend ontologies, and to ensure that data sets could be updated as the ontology was refined and expanded. And this is terribly important for subsequent work on data, whether by humans or by machines. There are researchers in a number of different disciplines who are trying to define a model or a standard for research papers of the future, where they've generated a number of desiderata that will help AI systems work on machine reading and text extraction more effectively. And this will allow AI systems and, of course, other scientists to be in a better position to understand articles and reproduce the results. One major use of the scientific knowledge we capture is to carry out systematic scientific data analysis. We can start with formulating a new hypothesis, determining the type of data and methods that will be required to test it, retrieve existing data from a repository, analyze it, and consider whether we can confirm or refute or revise our hypothesis. There is a lot of good work on reimagining the future of science and research, with a number of possible outcomes along the way. I can imagine, for example, that AI will be used to reproduce published articles or the results reported therein. We might see AI as a research assistant, or as a partner or collaborator, or indeed as a co-author. Maybe AI systems will significantly improve our approach to science and will end up authoring scientific papers with proper documentation and provenance. in the end, I think if we find imaginative ways to combine humans and machines, we will see really remarkable outcomes in science. Perhaps the question should be, what role will AI play in writing the scientific record of the future? And we're beginning to see some of that happen in practice. Springer, for example, was the first to publish a machine-generated book. I mentioned open science already, and I think there's a good argument that open science delivers scientific excellence at scale. And machines will, as I've said already, play a key role in delivering a new generation of services built on the principles of open science. At Carnegie Mellon, we will see this really accelerate in the next little while as the CMU Cloud Lab, which will be opened later this year at Bakery Square, springs into life. This will involve a couple of hundred pieces of automated instrumentation powered by robots and technicians, and generating vast amounts of data intended to support scientific reproducibility. I suspect that there may be a great high-T event in the Cloud Lab to come in a year or two's time. Just last week, the National Academies published a report on automated research workflows. The focus of this report is not only the use of AI methods and machine learning as a component in a workflow, but also the use of these methods to design experiments and to automatically control them. The goal is to use them in an iterative loop by using experiments or observation data to test and learn about models, and then to use AI methods to generate the design for the next data collection. To demonstrate replicability and consistency, the algorithms, their explanations, and associated data training sets should be archived by researchers in an institutional repository like CMU's KiltHub or a disciplinary repository. And we already know that libraries everywhere are providing strong support in preparing data and ensuring its proper curation, discoverability, and availability for reuse. And this allows other researchers to replicate the findings and make future improvements. Artificial intelligence now forms a part of various activities in the academic world, and undoubtedly it will affect how research libraries perform and carry out their regular services, and how the various kinds of data they hold in their repositories will be used in the future. Some of the things that we're seeing, for example, and this is really beginning to stray into Hua Jin's territory, so I'm going to be very brief here. We're seeing, for example, helping people in sharing their data, working with each other to prepare ML training data, defining the criteria for data capture, and the evaluation of outputs from AI. Librarians have a long record of providing training in working with the creation and reuse of the scholarly record. We are seeing great opportunities and huge demand at CMU for the programs we offer under the data software carpentry umbrellas. We are providing support in different aspects of academic programming to help people understand how to analyze large data sets and corpora, how to deal with copyright and text and data mining rights, particularly in the humanities. I think one of the key aspects of a librarian's contribution here is that we are recognized across the institution as being trustworthy partners across different aspects of research. And I illustrate here using our Enigma machines the extent to which we are seeing humanists who are moving into artificial intelligence and machine learning, and who are looking for honest brokers to help them develop skills in statistics and working with algorithms, and helping them to formulate the questions to pose of AI experts. And I think that's a terribly important role for us to build upon. Maybe I could illustrate an example here from a digital humanities project led by our colleague Chris Warren in the Department of English. His project, 6 Degrees of Francis Bacon, which was funded by a National Endowment for the Humanities grant. And here, Chris and his colleagues, including library faculty members, used computational methods to reconstruct and communicate social networks of early modern Britain. And they took the history of scholarship from that time, insofar as it has been digitized by libraries around the world, run it through algorithms to see how often different names have been mentioned together, and then model these relationships and build networks of likely collaborations. And that is a project that worked in collaboration with the Pittsburgh Supercomputing Center. It's interesting also to think about that project in the context of how we might bring voice to the historically marginalized. One of the things we need to recognize is that the historic record often speaks only to affluent white male participants. But if there are ways of collecting and identifying the underrepresented, we can hear in aggregate what's often too quiet to discern individually. Libraries often are seen as guardians of free and unbiased knowledge, algorithmic literacy, and ethical providers of access and democracy. And we've heard a number of points already about bias and how algorithms might reinforce racism and other negative factors. I've mentioned already the role of libraries as trusted partners in research communities, and I think we have an opportunity and a responsibility to educate students and all members of our community on aspects to do with bias, social justice, privacy, in our information literacy programming in the context of artificial intelligence. This is at the heart of our ethical principles. This is the UK professional body where I have my license to practice, and they very firmly are focusing on this as a current priority. Perhaps a different approach also is to, whilst recognizing the downside and the invasion of privacy that often people unwittingly expose themselves to by giving away their data freely. But maybe we need to recognize that there has to be a trade-off between AI and its users, that we might wish to give away our personal data to achieve better service. And that might be, for example, a personalized recommendation through a personalized search engine. And part of our role really is to help people make informed decisions, not only to see that there's a red flag and send them running in the opposite direction, but rather to make an informed decision about what is best for our individual circumstances. As I talk with colleagues, I hear of an abundance of rules conceived for libraries and librarians, their users, and artificial intelligence, as well as the tensions that are emerging. Libraries' motivation to engage with new technology appears to vary from techno-optimism, and I will confess to being more on that side of the continuum, to the fear of machines surpassing librarians, displacing our roles, eradicating human values. But undoubtedly, there has to be a middle ground where we can seek out the affordances of new technology whilst doing everything we can to identify and mitigate against their downside. I'm going to close by making a graphical observation. I've been talking about the fourth industrial revolution and AI and machine learning in different settings over the last little while. And as I look for images with which to illustrate my slides, what I see is that everything seems to have a blue background. And I couldn't resist on this particular week, and this is really for the British political geeks out there, just to observe the coincidence of human and machine intelligence. With that, I am going to stop sharing and hand over to Hua-Jin to take it away with the second part of the library's presentation. Over to you, Hua-Jin.
All right, thank you, Keith. I'm going to share my screen. Does everybody see my presentation mode? All right. Hi, everyone. My name is Hua-Jin Wang. Keith has laid out perfectly a nice landscape for the AI and data and open science in the scholarly, in the evolving scholarly record. And my part of the talk is going to focus on the data part of, from the data point of view, how to make data and workflow fair in supporting AI applications. FAIR here stands for findable, accessible, interoperable, and reusable. And I'm going to talk about this a little more later. So there's lots of data being produced from research, especially with the advancement of technology and engineering. The research data has been becoming more and more complex, large, and multimodal. This makes the task of data processing and data analysis more complex and time-consuming as well. Since the process of creating data is so expensive and time-consuming, in the ideal world, it would be makes the most sense if if all of the data and data processing workflows and analyses details would be preserved and shared so that they can be reused to generate new hypotheses for others to reproduce or replicate the results, and provide more training data for machine learning and AI models, and develop computational tools that will come back to help data creators with the analysis. But in reality, only very small amount of data these are made up numbers, but the concept is like only very small amount of data gets shared in the form of publications and the supplementary materials as well. But the majority, especially the intermediate raw data, as well as protocols and workflows and codes, live on researchers' computers and hard drives and on lab servers. And if the researcher leaves the lab or moves, the data will not be found. So as a former biomedical researcher, and I moved the labs a few times, I can totally testify for that. And often the problem is also that even if others have found the previous person's data, because often the data is not well documented, it's hard for somebody else to use the data that they didn't create. So this is frustrating, but the good news is that with the uprising of open science initiatives, and there has been increasing demand from funders and publisher mandates, and from university recommendations to share research data and the intermediate product, and more importantly, individual researchers, especially in the disciplines like genomics, also realize that data sharing helps them to get credit for producing the data code and the workflow and reach wider audiences and build more collaborations. So as a consequence, more data are getting shared publicly. This is a great first step. But a lot of them are still on the researcher's website, and some of them made into the repositories. And the problem is also that these shared data are often distributed across many websites and data repositories. And the only small amount of these data are searchable. So of all the data shared, there's a very small percentage of the web data are structured data, and most of the repositories data are also structured. These are the data that are easier to work with, but the vast majority of the web data are unstructured. So by saying structured data, I mean like has a metadata embedded in the HTML like this. So vast majority of the data are web data are unstructured, and a lot of the information also are hidden in publications and figures and text. So these are the data are not necessarily reusable. So shared data not necessarily means reusable data. To make the data more suitable for reuse and for AI applications, the best practice, the recommendation is to follow the FAIR principles. This is a set of principles that's first been discussed in many years and formalized in 2016 in the Nature Scientific Data. So it stands for findable data should be associated with appropriate metadata and have a persistent identifiers, so that is discoverable by others. Accessible, it can be easily retrieved through a persistent identifier, not hidden behind a paywall, and the identifier should not change over time. Interoperable, use the data format that are open or widely adopted and not require a specialized software or metadata standards. Reusable, and this is sometimes interchangeable with the reproducible as well, meaning that data and metadata should contain enough details so that others know how to use and build on it, and also entails that appropriate licensing is associated with data to allow reuse. The FAIR principles initially developed for data, but also can be extended to other forms of research products, including code, models, and computational workflow. So when I talk about data in this talk, keep in mind that I also refer to these other types of research products. So FAIR sounds like a very simple set of principles, but in reality is actually can be very difficult to achieve. It can be difficult to find data even for the structured data and created data in the repositories. It's difficult. There's generally no overall discovery layer across the platforms. It's not always easy to access the data because data retrieval constraints, privacy concerns, or because maybe the URL is broken. The data might not be interoperable. Excuse me. Might not be interoperable because the data is not shared in the way that's machine readable or sometimes even a human readable, or is using a proprietary format. And the data may not be reusable, especially for AI applications, because the data is not accompanied with good metadata standards. And oftentimes the good metadata standards just simply do not exist for certain disciplinary data sets. So it is just really very difficult to share data in a way that is fair. It takes a lot of work, both for data owners and data curators. As librarians and information professionals, one question that we think about a lot is, in the era of machine learning and AI can automate so many aspects of our lives, can AI also do something to help making the data more fair? And this was initial motivation that we created the ADAR conference, Artificial Intelligence for Data Discovery and Reuse, in 2019. So it was initially funded by NSF and now intended as an annual event. It provides a venue for researchers from all disciplines to talk about research projects and to share challenges, the research projects and their shared challenges using AI to facilitate data discovery and reuse. So we've had two iterations of these events and a few recurring themes I'll try to summarize over here. For example, using AI to help find data, to help with data curation and to detect and fix problems in the data. So I'm going to discuss a few examples. I'm not an AI scientist, so just the technical aspect is going to be very superficial, but hopefully I trigger some thoughts from the data perspective. So to address the findability issue, just the discovery across different platforms. There are many search engines being built to help find data, and one of the most prominent ones you might know is the Google dataset search. So the user, you can enter the keyword to search across the web and to find the data sets and specifically the structured data. What the search engine does is actually it does not look for unstructured data. It only looks for metadata in the structured data in the repositories, government data, databases, and using specifically this schema 3, the schema data standards. So when you search, enter a search phrase, it returns the relevant data sets from these web domains. Often these are all different data repositories. And then so gives you the data set, the metadata information. So there's being mixed reviews on how well the Google dataset search works, but it's a good first step towards the right direction. But really the limitation is also that it works only for structured data that are using the schema 3 annotations. For unstructured data, the job is a lot more complicated and messy without the metadata tags to work with. And in this case, the data curation and annotation will need to be done first, and usually it's a very labor-intensive task. From the library's perspective, take the archives, for example. Archivists often face the problem of manually going through thousands of images and label them with the right metadata and annotation. So this project shown here is called the computer-aided metadata generation from photo archives, led by my previous colleague, Matt Lincoln, in the digital humanities. So he built an AI-powered tool to find all the images that's similar to a seed image selected by the archivist, and then generate a metadata list for those images. So, of course, like with this project, the final validation of the metadata tag still need to be verified by an archivist, but saves a tremendous amount of time. This example here comes from rare diseases. Because there are often not enough patient samples in rare disease research, it's really hard to have enough data to train machine learning models in this domain. This example is adapted from Dr. Casey Green, who used to be at UPenn and now moved to University of Colorado. They are solving the data scarcity problem in the rare diseases by a technology called model transfer. So his group built a computational toolkit. First, uniformly process and quantify large amounts of gene expression data from public domains, from open repositories, and then build a model to automatically extract the patterns that correlates to biological pathways. So each lane here is a biological pathway. And then you can transfer the model to learn that you learned from large amounts of public data to the small amount of rare diseases data. And then with this information, users can start to predict, users can start to predict how these pathways are changing in comparison to the healthy controls. And one of the most challenging issues in reusing the biomedical data is actually the need to extract the information from data sets that are so heterogeneous and come from multiple sources. And this multimodal data are often hard to reuse because each data set have different format, vocabulary, and metadata, and need to be harmonized, integrated before they can be analyzed altogether. So this example I'm showing here came from Dr. Tom Mitchell from the School of Computer Science. So they study building the machine learning models, try to understand how brain processes language. So they have large amount of text data. So with this, they can train machine learning models to understand relationships with the words and predict what comes next. And then you have moderate amount of brain imaging data from different imaging technologies. When subjects are shown words or paragraphs of text from here, then the brain activity images can be correlated to words. And combining all these information together, they can start to understand how the brain processes language. You can see that this is a very complex case of harmonizing many complex unstructured data. And by the way, all these different types of brain imaging data tend to come with different metadata standards and different data formats. This is a sticking point for the neuroimaging community, and now they're starting to come together and starting to consolidate, address this problem. So in his talk, Tom Mitchell, I want to highlight a few of his points. He mentioned that there's a huge opportunity right now to jointly analyze data from many data sources that contain very rich information, but there are many hurdles exist. There's a need to develop methods and tools to help analyze the data jointly, because right now, currently, it's just not clear how to do that well. There's a need for an open culture to share data so that they can be used to build machine learning and AI models, because the models tend to need lots of data, and not all data out there are available or well annotated. There's also need for data standards and controlled vocabularies to properly describe the details of the various experiments in the way that the machines can understand. So all these point to the human factor in using AI to make data more fair, more findable, and reusable. So machines are good at certain things, but humans are still always important to define the ground truth, offer expert opinion, and provide guidance for the machines. And we all know that AI is not magic. It's only as good as the data that it is provided with. And for example, in order to get AI to successfully perform image segmentation for self-driving cars, humans have to first tell computers where the road is and where is the pedestrian crossing before the AI can start to learn to do the task. But the high quality labeled data is just really hard to find. So as humans, there are several things I think we can do to make it easier for the machines to do all these amazing things better. First, do our share of work in the data stewardship. Here again, data is loosely defined. It also refers to the code, models, workflow, or other type of research outputs. So document every details of the experiments in a way that machines can understand. Be thoughtful with data curation. By that, I mean it's more than just fitting all the data in a repository, but one important factor in the data curation is also to develop data standards that are suitable for specialized data, and a standard that the whole research community who are working with this type of data would agree to use and comply with. What comes hand in hand with data stewardship is also open science, and Keith has laid out this point clearly in his portion of the talk. So the key to open science is adoption, to make science a part of the research culture and make it a norm instead of a heroic action. So make the data code and good data code sharing as something as obvious as using the right reagents to run experiments. And this should be part of the incentive structure as well, so that open science practices would be evaluated for this as a scholarly output alongside of publications. Another piece of key piece of in open science is also to make data sharing easy to do, so that there's a minimum burden for researchers to adopt. For this, I think the data scientists and AI researchers have duty to develop easy to use and robust tools and infrastructure to make the sharing part as easy, and not only for code, data, and workflow, but also for the data standards themselves as well. And the interaction between AI and data also implies that researchers from experimental science and computer and data science have to work together. I view the cross-disciplinary collaboration as an interoperability issue between humans of different backgrounds, because data creators and computer scientists will need to learn the same set of vocabularies to make sense of the data or the analysis before they can collaborate properly and work on a problem iteratively. And the key for the collaboration and communication is to provide basic training to lower the communication barrier so that everyone is on the same page. And finally, a huge human factor using AI, as other panelists have pointed out, that is the ethics of AI. More data is not necessarily better when using AI applications. I think the human factor is not just there to create the bias in the algorithm or in the data, but we can be a source of bias and source of bias as well during the data collection or annotation or interpretation. So I think Rachel said is spot on. The responsible AI is a key. We should ensure the accountability in decision making, and rather than in decision making that is so that we're able to offset the intrinsic uncertainty for the AI applications. And now I want to switch gear a little bit and touch on the library's role. Because libraries has been playing a role in maintaining the scholarly record in the data curation and preservation and providing tools and information for a wide range of research communities, I think we're ideally situated at the interface between the technology and human factors, human solutions for fair data and for the AI applications. So there are many services that intersect with and support the data and AI activities. So Keith has also already mentioned digital humanities. We also have data services that helps with the data curation and provide a policy guidelines and provide infrastructure. Then the archives also provide a lot of data source and also have cool projects like the robot archive to preserve the artifacts in our AI research. So I'm not going to attempt to summarize all these cool activities here, but I want to offer an example of the Open Science and Data Collaborations program, which I take the lead on. Okay. So we created, my colleagues and I created the program in the late 2018 to help researchers practice open science and navigate open science policy. Currently, our program has 5 pillars. So by providing open science, we provide open science tools and platforms and train people on the open science concept and basic data science skills, and try to make practicing open science possible and make it easy to do. And we often organize community building events to get researchers to share their success stories and talk about challenges and solutions about practicing open science. We also have facilitated collaborations across disciplinary boundaries and try to make it fun and rewarding for researchers to share their data and workflow. And recently, we also have assessment services as well. So by offering this service, we really want to build a program that provide an end-to-end support throughout the entire research life cycle of research. Sorry, excuse me. Not only the end product, but also the planning, the workflow, and also the intermediate results and the analysis. Yeah, sorry about that. So we understand that different individuals or disciplines have a different understanding and comfort level of sharing the research product, and we try to support a full gradient of openness and meet researchers where they are. And for example, for those of you who might work with sensitive data and cannot share data for privacy or IP reasons, we'll help you to be aware of the open science tools and methodology that can be used, and start thinking about sharing at least part of your research workflow, your research product, if not the raw data, maybe the aggregated data, and think about optimizing for visibility and reuse. So here I want to offer two examples that I realize my time is coming up quickly. So I want to offer quickly going through two examples to how we tailor our open science services to specific research needs. The first example is the BOLD 5000 data set from Marlene Berman's lab. One of our former colleagues, Anna von Gulik, helped with the data curation to help provide some guidance on how to optimize the reuse of the data set. And this data set is very unique because it's fMRI brain scans data while the volunteers are viewing images. This data set is unique in the sense that it contains much number of images than what's normally used for fMRI research. So it's just makes it possible for computer vision scientists to use this data set to train deep learning models and study how human vision works. So the data set we help them to share in the GitHub, that our institutional repository. And you can see that the benefits of sharing here is pretty clear that this data set has been downloaded so many times since the 2019 when the data set is uploaded. And is helping the researchers get a lot of the to get the data set cited, the independent of the paper. So anybody who uses the data set would be able to cite the data directly. So the next example I want to offer here is the academic cloud lab. Okay, I'm going to try to go over the rest quickly. Oh, I'm sorry. I realized that there was no audio. Okay, I'll share the link later. So with the academic cloud lab, like as you can appreciate, is from the automated remote controlled lab. There's a lot of data being produced. It's really valuable for the potential reuse and for AI applications. But at its current stage, it's based on commercial platform with a proprietary data format and requires a CMU account to access the raw data. So the question is how to make the data from such enclosed commercial platform to transform that into academic setting and allow sharing the data into the public repositories. So my colleague and I have been helping to develop workflows and help researchers to make decisions on what components to be shared and into what repository. And as a proof of concept, we are able to develop some automated data upload from the Cloud Lab into the GitHub and automatically generates README files that contain enough experimental details and metadata. And in parallel to this, we also support the future Cloud Lab users by providing monthly trainings on open science and basic data science. And this is in addition to what Keith mentioned before, that data carpentry and software carpentry type of basic data science training. The goal is to help researchers to learn about open science concept and tools and be comfortable with with a reproducible computational workflow and some basic terminologies before they get even started using the Cloud Lab and do the data exploration. And Cloud Lab users, as you can imagine, create a lot of data and many of them who might want to collaborate with the data scientists for more sophisticated data analysis. So for this, we have a data collaborations lab that connects data holders and data scientists to work on the shared data science projects. And so far, we had 20 plus projects. Many have to do with AI applications, and some of them went as far as publishing papers together and write grant application together. And in addition, we're supporting all these efforts by hosting annual community building events. I've mentioned ADAR before, and another one we have annually is the Open Science Symposium, where researchers can come together to talk about share their success stories and open science tools that develop. So in the next iteration, I will be excited to invite Cloud Lab users to share their experience and learn from each other. And finally, I want to circle back to the FAIR data and the workflow and its interaction with AI. So what I want to getting at from all this is that for AI to realize its best potentials, the human factor is really important to ensure the success. We need to build healthy data ecosystem where researchers are diligent about documenting and share their data and computational workflows and follow the FAIR principles. And research community and data curators would build and maintain high quality data standards. And make them open and non-proprietary, and institutions and infrastructure providers support a wide range of provide robust platforms to support a wide range of data sharing needs, and tool developers try to make it easy to use tools to support FAIR data and make it open source. And with all these in place, we'll hopefully start to be able to extract massive amount of value that are locked in a massive amount of data. So with this, thank you, and sorry about this this COVID symptoms. That's after 10 days, I'm still recovering from it. Oh.
All right, thank you so much. Thanks so much to both of our presenters. From Keith Webster, we heard about emerging trends of AI in the research, publishing, and library landscapes, and discussed the opportunities for libraries to support AI education and research, as well as opportunities afforded by AI to advance library priorities. And from Hajin Wang, we discussed technical and human solutions for making data fair, findable, accessible, interoperable, and reusable. And she shared her view on the essential role of building a healthy data ecosystem to support AI research, as well as the services offered by the Open Science and Data Collaborations Program at the CMU libraries to support AI work. So thank you so much. We heard a lot about the enabling and supporting roles of the CMU libraries. So when you're working on AI, remember the CMU libraries and the resources available are there to help. Whether you're looking for advice on ontology, data sharing, data discovery, or training, these are invaluable resources at your disposal. So now we'll have some time for all of our panelists and presenters to answer questions. So audience, if you have any questions or comments, please use the Q&A feature to submit. Or at this time, if you'd like to come off of mute and ask a question live, you can raise your hand and our IT host will give you the ability to unmute your mic. So we do have one question from the audience so far. So we will jump right in with that one. From Caroline Coward from NASA. The question is, are CMU librarians involved in ethical AI policy development, perhaps in partnership with SEI engineers? What direct benefit to both institutions do you see from this involvement? I think that one, yeah, if Keith wants to go. Thank you.
Yeah, maybe I could jump in there, thanks. The quick answer is no, we haven't had much engagement to date, but we would be happy to do so. It's wonderful to be at a university where there is so much leading research in AI and machine learning, but what that means often is that there truly are world-leading experts in any aspect at the university, and we see that very much in the AI ethics space with colleagues like Alex London in Dietrich College, and we very much look to them to be leading the policy development. Where we see a real opportunity is to take that work and repackage it into informative guidance for our students, amongst others. Where you will see on our website is the work that we have done in helping people understand as they use library services. And by those, I really mean publishers, platforms, recommender tools, and the like. What are the issues that they are dealing with in handing over some of their data, just as I described towards the end of my remarks? So we very much are ready to be part of that conversation. I hope that we recorded Alex's soundbite, because that really makes for a great commercial, that we stand ready to help you on all fronts, and that absolutely is true.
Thank you so much for your answer there, Keith. So we heard a lot about the interdisciplinary collaboration, and CMU libraries are working hard to enable this interdisciplinary collaboration. So this is kind of a question for all of our participants here today. What else do we think we can do to promote interdisciplinary collaboration and open science between academia, industry, and government?
So, Alex, I think I'm going to come off and talk a little bit about that, if I could.
Yeah, thank you so much, Tom.
Yeah. So, the interesting thing about CMU is that, although collaboration is one of the key factors in everything that we do across CMU, and that includes places like the SEI and NREC and all of the other institutes and things that are around, one of the most difficult things is actually finding one another. actually finding one another and understanding enough about each other's work so that we can begin to come up with those new ideas in collaboration. I think as we're coming to really the other side of COVID and the other side of what's happening here, we do have an opportunity to attend more of these joint sessions that are cropping up within all of the various departments and colleges. And I know that library science, sponsors some of these. If high T were in person, we would have side conversations that might start some of those things up. So the way I would really think about this is to encourage over the next year, between now and the next time we have a high T, really making sure that everybody sort of participating here today has reached out and really talked to somebody at CMU they have not yet talked to with regard to their research, a department, perhaps a place that they haven't really worked with before. This is, in my mind, the way that we can begin to move into the use of both AI engineering and AI within library sciences generally to really up our game across the whole university. We have the theory. I think we need to up the practice, and that's kind of where it needs to go.
Thanks so much, Tom. I'm actually probably going to call on you for this next question too. I'm curious, I think you talked about this a little bit, but if I'm really interested in getting involved in AI engineering, how can I do that? Are there any internship possibilities or anything like that?
There's a ton of internship possibilities. The SEI, we take on many interns every year. And within all of our organizations, whether it be in the software realm or the cyber realm, or within AI and AI engineering. So we are always open to interns. If you can't find where to actually connect with us on the internship, send me something directly, tal@thesei.cmu.edu, and I will make sure you get to the right place. But throughout the university, these opportunities abound. They really do. And one of the most difficult things might be finding all of the ones you are interested in. But again, a little bit of investigation across the university. Most of the websites have direct links into how you might participate directly as an intern. And I will say also that the SEI, as well as many other places across the university, we are hiring. And we absolutely want your application as you're finishing up. As Matt had pointed out, don't have to have a PhD. Come to us when you are ready to work in some of these areas. And I make that pitch specifically for the Software Engineering Institute, but it is also true in other places around the university and beyond. So, set your sights on some of the things that you might do professionally to go beyond just sort of a summer of collaboration and join us permanently.
Thank you so much for that answer, Tom. Well, we are wrapping up. We're coming up on time here. So I just want to say thank you so much. Thank you to all of our attendees for joining us today. Tom, we got one more question from Caroline. She wants to know if we offer fully remote positions. And right now we do. So thank you guys. Oh, go ahead.
I'm going to say, ask. Call us, ask. We do all of these things on a case-by-case basis, and we are open to a number of different ways that we can work with you. So whether it's remote, local, whatever it's going to be, talk to us about it. We are happy to engage.
Exactly. Thank you. So thank you so much to all of our attendees for joining us today. Thank you for your questions and your engagement. It really goes to making a great event for everybody. Thank you as well to all of our presenters. We so appreciate your participation and generosity with your time. The recording of today's event will be posted on the SEI's website in our digital library. For more information, and if you have any questions, please email info@sei.cmu.edu. To everybody here, we hope you have enjoyed this year's high tea and the actual tea, and that you leave today informed and excited about the SEI and Carnegie Mellon University's continuing impact on the future of artificial intelligence engineering. Thank you so much and enjoy the rest of your day.